Welcome back, generals, to another Let's Fix Generals at Zero to make the best game ever. Okay, so last session we have implemented a bit more here on the base class virtual table stuff. There was an assert being hit, if I recall correctly. Let's see what that is about. Yeah, this base offset assert was hit. Yeah. Somehow Visual Studio is very slow right now. Build started and it doesn't start. Yeah, it's just hanging. Typical Visual Studio. Yeah. There we go. Maybe it's operating system slow as well. Okay. Jesus Christ, why is this so slow? It's so slow right now. Nothing works. Debug error. There we go. Look at this, how slow this is. I press on retry and it takes, I don't know how many seconds. My gosh. Something is clogging the system right now. Probably some process being super busy. Maybe we can take a look at what it is. CPU. Doesn't look super suspicious here. Aha, no. System idle looks good. I don't know. Should be fine. Even scrolling is buggy slow. I don't get it. Okay, so this assert is hit. Base class offset is 4. Good. Why is it 4? Index 0, classes. Base class index is 0. Base class index 0. Yeah. Class index. Watch. Base class is 1. Base class is 1. Base offset 4. Base offset 4. Okay, let's go. Let's see what class are we looking at. The class is Skirmish Battle Honors. Good. Skirmish Battle Honors. Let's search for type info for Skirmish Battle Honors. There we go. No? There we go. Good. So good. So it has type info. What if we go to vtable? Vtable here. So there is offset 0 and then offset 4. Uh-huh. 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 Okay, so it inherits, the user preferences inherits std map, and that has an offset of 4 for some reason. User preferences load right. Load right. Load right. Type info 04. I am surprised that std map is not at offset 0. Right? Why does skirmish battle honors? Why does it inherit user preferences? Ah, well, okay. I see. Okay. Yeah, maybe. Okay, but I don't understand why SCD map offset 4. Offset 4. Offset 4. Maybe because it doesn't have a vtable. Could that be? Yeah. When it doesn't have a vtable, then it's not at offset 0. Could that be? Maybe. Yeah, maybe. Yeah, maybe. Okay, then we need to make some change. So right now it expects that every first base class is at offset 0, but then that's not the case. So then when we need to say if if base class is not at 0, then we break out. Break. Base class without virtual, without vtable is not at offset 0. Yeah, that's my suspicion here. Yeah, and if it doesn't have a vtable, then there's nothing to override, and then we don't care anyway, right? No. Okay, so I suspect that this will work now. Maybe. Yeah. Then I wonder if this depth here is correct. Base class, get base class depth at offset 0. Then we need to say also here if base class, then we also break here. Maybe we put the comment here. And then we also put the comment here. Oh, it cannot break because it's not a loop. Then we do if this, then we go in here. Okay. I think that will work. Base class depth, yeah. Let's see. All right. Okay, so if we don't hit an assert now, then we will be interested if we hit this one here, and we do. Okay, but at least no assert anymore. But I think it makes sense that we still hit this because we did not yet process the we did not process something yet. Yeah. Okay. Well, then what our upgrade module interface? We have a pure virtual entry at index 4. Yeah, and it's unknown. Just one. Okay. It's Interesting. Okay, let's see how many more. Here we got another one. 1, 2. Pure virtual. Yeah. Is pure virtual. How about we say we make a count here? Count int pure virtuals with name 0 and pure virtuals without name. I would like to know like how much we covered now in numbers. So we say if name is empty, then we put this here. Else we put this. And then we put a breakpoint here. Good. So we have 1,205 pure virtues with name and 11, just 11 without. Look at that. Just 11. It's not much. But why? Pure virtues without name 11. Huh. So I wonder, what are we missing then? I mean, we do have all the secondary vtables covered and all the primary ones. So why are we missing some? Let's look at the cases. Let's remove this here. Test. Yeah, let's see what they look like. Why don't we have the name? Okay, so we have, what do we have? Upgrade module interface. Yeah. Upgrade module interface. Upgrade module. I mean, here we override. I wonder how much, if we remove this here, if we remove this one, how much do we get then? So it's now just processing the primary vtables. And then we get, ah yeah, okay. Okay, so this is, we need this here, okay. Okay, but we still have 11 left. Okay, then let's look at, we probably need to find what inherits that class. Right now we don't have any linkage from a base class to all the classes that inherit it, right? Yeah, how about, hold on, we need to put a breakpoint here. But I have an idea how we can possibly debug this. Okay, so class type update module interface. Good. Copy the value. Shall we just copy the name here? Yeah. Copy value. Okay, and then we put a breakpoint. We put a breakpoint at base. Put here if base class type dot name equals this name, then we put int a equals 0 and put a breakpoint. This is test, and then we do the same. Do the same here. Let's put it up here. There we go. Okay, then let's take a look at it. Why we are missing filling the names for some for some thingy. For some pure virtuals. Okay, good. So here we are. Upgrade module interface. Our top class is upgrade mux, whatever that is. Okay, let's see. So vtable count, base vtable count is 7. Base class base m vtable entry 7. So right now they are all pure virtuals. Yeah. Okay. So entry. Okay, is already upgraded. Is pure virtual. Is detour false? False. Is pure virtual entry. Upgrade mux is override. Yeah. If this is not pure virtual and this is pure virtual, then base entry name. Okay, so here we set the first one. Upgrade module interface is already upgraded. Yeah. Okay, so this looks good. Next one. Next. Attempt upgrade. UL 128 UL. Is detour. Base is detour. Okay, is override. Okay. Yeah. Okay, Okay, same thing here. There we go. Okay. Reset upgrades. So far it looks good. All. Go in here, yeah. Entry. Okay, so here we have a pure virtual. Is pure virtual. Yeah. And so this is this is implicit then, and we won't go in there. Okay, good. So this was the first time where basically we have a pure virtual that is not being overwritten, right? Here, entries. We have multiple, 1, 2, yeah, that are not being overwritten. Okay, then let's see other cases. So that was which number? Number 4 and number 7. 4 and 7. Yeah, not 4 and 7. Okay, let's keep that in mind. Let's actually do the following. We take this guy here and we put it into the watch here, and then we copy this guy and we put it into a text document here, like this. Yeah. Okay, then let's put another breakpoint. Oh, that was it. Oh. Okay, so there's only one class that huh? Huh. Huh. Okay. So there's upgrade MOOCs. Okay, what about some other case? So that was this one. Let's see the next one. Parameter class. Copy value. Parameter class. What else? Another parameter. Definition class. And call system class. And okay, that's only 4 classes. That's good. Actually, let's leave this breakpoint here. Okay. Then let's leave the breakpoint here. Let's put a new one here. Let's put the parameter class in there and the definition class. Definition class and the call system class. Yeah. And then we take this guy and we also put it here. And then we put breakpoints at all of these. Yeah. Good. Let's restart and let's collect the tables of all of these guys. Yeah. Yeah. Parameter class, definition class, call system class. I mean, I would expect that all pure virtual functions are overridden. Otherwise, the base class is unusable. You can't instantiate a class that has a pure virtual function. Right? So I would expect that all are overridden. Yeah. Okay, so we got this guy already covered. Yeah, let's go. Okay, maybe these are never used here. Upgrade module interface. Huh. Is this already here in Thyme? Let's see. Yeah. Upgrade module interface. There they are. Look at that. Test upgrade conditions. Okay, so this one is sub-object upgrade. It's not being overridden. And then we have upgrade MOOCs. Maybe it's just never used. Yeah, it could be. It's never used. So here it's already all implemented in Thyme. But it looks like it's never used. Upgrades. Let's see. Is this ever... Oh, upgrade MOOCs is used here. Upgrade module. What about upgrade module then? Upgrade MOOCs. Upgrade MOOCs. Ah, look, so this is now, this is a base class with an offset, and I think we haven't processed this. I think that's the problem. Yeah. We haven't processed it. Yeah. But we have, hold on, upgrade MOOCs, upgrade module. Upgrade MOOCs, it should have. Ah. I think I understand the problem. Or do I? I think what we need to do is we first need to process the secondary tables and then afterwards the primary tables. That might fix it, yeah. Let's let's try this. So we move this up here. So vtable, oops, vtable index. So index t vtable index equals 1, and here vtable index. This might actually fix it, yeah. Let's see. No. No. No, still 11. Okay, so this didn't help. Okay, well then we can move it down again. Okay, it's interesting. Then how about so space vtable. Let me find the base. If I, what if we move? I really would have thought that if we move this, if we process the secondary vtables first, that this would work, but somehow it did not. Why not? I'm not sure why. So the problem I see here is that this upgrade mux is here, and then so basically this thing here is not overridden by this, right? Oh, it's also not overridden here. So after reset upgrades, this one is not overridden, and test upgrade, and this one. This one. Upgrade implementation. This one. This one and this one. Okay, let's focus on this one, yeah? Okay. Here it's being overridden. Yeah. Yeah. Okay, then okay. I see. So we probably need to. I see. I see. I see. So this one is not going. I see. It's probably breaking its link when. So it's not a straight line here. It's not all base offset 0. There is a base offset. Base offset. Some other. So. So I wonder if we are missing something here, maybe. It's detour. Yeah, I'm also not sure if this is here correct. Is detour. Maybe it is. It's detour. Maybe. Oh, this is a problem, yeah. We are still missing something. I see what we are missing, but I don't know how to elegantly implement it. Yeah, the problem is that we have in the top here, this is a primary vtable here because there's only one base class, but this one overrides something that is then in a yeah, it overrides something that is not in a primary vtable somewhere down the line in the base class. Yeah. It's not in the base class at offset 0. And that's why it doesn't find it here, because here we are only looking at the Well, actually, that's correct. It's not base. We're looking at all base classes, no? Or not? No, we're only looking at base class at offset 0. Yeah. Yeah, I think that's a problem. That is a problem. Okay, but if we look at other base classes then we have a problem here, I think, with this detour thingy, destructor. Yeah. Yeah. We probably need a mix of this one and this one in one loop. Or how about secondary? Yeah, it's secondary base class. Base class. Yeah, I think we don't do it quite right. Yeah. We don't do it quite right. Oh, this is yeah, disappointing. Disappointing. Okay. We probably need to visit all. We need to visit all base classes, not just the primary ones. So we need to. Actually, when we. Yeah. Oh boy. Yeah. Also, when we iterate through the primary vtable, we also know. Yeah. We probably need an algorithm that can also visit not just the base class at offset 0, but all base classes. Yeah. Yeah. Okay, how about we comment out this one here? And we comment out this one here. And we make a copy of this and start a new loop. Okay. Copy. Yeah, that's okay. We can test. Then we put a breakpoint in here. Okay, we make a new. Okay, so we don't. But we need to start at base. offset. Do we? Do we need to? No, we don't need to start at base class index 0. Base class index set offset 0. But this is a nice information here, but we can still get it. Okay, how about how about we say base class index yeah, we don't do this, instead we do get base. I think what we need to do is at first we need to make, or later need to make some changes here. I think let's put vtable index vtable index int detour count 0. Then we say if base is detour count detour. Let's do base detour count. Oh, actually, hold on. Yeah, actually, no. If we overlap to another base class. So I think this is correct without this here. For the purpose of just going over the first, over the base class at index 0, at offset 0, then this is fine, I think. But if we also go over the base class at an offset, then I think we need then we need to count the base detour, base class index. Base class index. Base class. Base class at 0 index offset 0. We also need here to iterate all base classes, but Base class. Okay, base class. Oh, we tried many things already, and none have worked so far. Or not properly worked, let's say. Yeah, but I think we can get there. We just need to find the right handle on this. Primary vtable order. Yeah. It's implicit. I was happy with this algorithm because it's pretty simple, but yeah. It's not complete, that's a problem. It's not complete. Base class. Oh man, why is this so complicated? My gosh. Okay, how about we try a void process primary vtable. And then we give it a class type. Okay. And class type and and then vtable entry index 0 index t vtable entry index. I really hope that I will find the proper way to do this. My gosh. By the way, this one, how about we comment out these guys here? Because, yeah, we have more and more functions that we don't actually use. Right? Yeah, it's getting more and more. So much code we don't use. Yeah, let's comment it all out. Okay, we try a new function. Well, we are missing something here. We also need to give a base class. Maybe base class. Base class. Okay, and then here we call process primary vtable. Actually, we need to do for base class vtable index base class class type base class class type dot base classes process primary vtable class type base class. That's it. Actually, vtable, we call it yeah, I don't know what to pass here as a vtable entry index. Okay, for starters, let's copy all this garbage here and here. Vtable index. Assert not dot size larger equal 1. So we have vtable entry index 0. Vtable entry index. Oh man, I don't understand how to iterate this bullshit. Oh, that is some complication, man. Why? My brain is not capable enough for this bullshit. Index T. Oh man, it's so complicated. So if we have a base class, yeah, base class, retail entry index. Oh man. Okay, I think we should call this top class, maybe top class type. Top class type. Okay. So I'm thinking we should say top class type. And then here we say for base class. In our class, get secondary vtables entry count. Vtables entry count. How about we say get how about we make a span get vtables entry count, and then we give it a number. UN32T count vtable count from end. Yeah. Vtable count from end, and then we say that is totally wrong here, isn't it? Vtable count from end. We make an assert vtable count from end. Vtable count from end is bigger. It's bigger. Vtables dot size. Now it's smaller equal. Count. Then we do for UN32T I equals 0. We do mvtables dot size minus that. No, vtable size minus 1. let's do while I let's go I0 I is smaller than this plus plus I, and then count vtable vtables I vtables dot size -1 minus I dot count. But this is with all with this is with destructors. Oof. This is with destructors. How do we count this when there are destructors in there? Oh boy. I don't know. Yeah, we can maybe. Okay, let's remove this function as well. Yeah. Oh boy. How about we return a index t? We return an index t, and then we pass it. So we yeah. Index t. And then here we would also say for is a base class type base class index, and then we would do the same here. Process primary vtable, and we do here base class type, and we give it top class here, base class, yeah, But then we have a problem when we reach oh man, so complicated. The problem is now when we reach the when we the problem is the vtable index. That's a big problem because of the A virtual destructors and B of the base classes as different offsets. It makes it so complicated to locate the proper location where they what they belong to, what they overlap, where they overlap. Ah, it's so bad. It's so bad. Oh man. Why can't it be easy? Yeah. Yeah, I'm not sure how to implement this. There's probably a very easy way, but I just don't see it right now. I don't see it. Yeah, I tried many complicated things already, which worked in part, but it's not the full picture. That's the problem. So we need to walk through over all base classes, which I would do here, right? this would now walk, and we would always have the top class parsed. But maybe we shouldn't do that. Yeah. Maybe we should only delegate from top to bottom. Yeah. Maybe it shouldn't be top class type. Maybe it should be class type. Yeah. And then here we pass a base class. Base class. What is in the base class? I don't know. Base class. Yeah, but now we would basically need to get this index right here, and I'm not sure. I'm not sure about that. So if base class, what we can do is base class. Base class. Let's think about it a little bit. Yeah. Take it slow. Take it slow. So if a base class is not at 0, base class, base. How about we put this comment here? No, I can leave it here. It's okay. Class type base classes. Let's stop debugging. How about think this composition is totally wrong, isn't it? Class type. Base class type. Vtable index. Zero. How about here we provide a class count. Perhaps we should have a function count, and then we say int or uint 80 subtract detours. Actually, we can subtract. Yeah, subtract count. Why don't we? How about we? Hold on. How about we just have a struct vtable. Sorry, I will be right back. Yeah, Okay, let's try it again. How about we have a function that returns vtable entry count, where we have regular, let's say just a detour count. Maybe we just make an int, sorry, to int. Let's just make a uint 16t detour count and a virtuals detour count. Virtual count. Virtual count. Or let's call it non-detour. Detour count and non-detour count. Or let's say regular count. All virtual functions that are not destructors. Virtual destructors. Typically 0 or 2. Not destructors. Okay, and then we have a function that returns this vtable entry count, const, and then we remove all these guys, count, count here, count, and then we need to pass these two functions, count, and then we have a function uint 16t all let's just say combined count, just combined const return detour count plus combined. Okay. Retail count, combined count. Okay, and then here we do this here. Count entries. Why is this? Oh, vtable. Vtable entries. Vtable entry is destructor. Count is detour count dot detour count plus plus if Let's also have a function uint16t simple combined count. And that just returns this one here. Yeah. Combined count. So static cast. This. Yeah. Right. Count if else count dot regular count. There we go. Okay. I think this is good. Maybe. Combine count. Why is this not found? Ah, there we go. Okay, let's try this. Okay, so basically we now have a vtable entry count base class entry count dot count. No? Dot vtables 0 dot count functions thunks. So can make it const. So yeah. And then we should be able to say here, how do we say? Oh man, I don't have the brain capacity for this right now. It's unbelievable. So we give a 0 here the first time, which is fair. And it refers to this one. Good. Then here we also give 0. Zero, zero, zero. And then when we reach yeah. I'm basically at the very start again. Oh man, this vtable stuff is amazing. So complicated. Okay, but I think vtable entry count will help us to 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 get the right counts. Yeah. Okay, so base class entry count. How do we do it here? Vtable count without detours. Base vtable index. Base vtable index. think what we need to say here is primary table. Table index. I don't understand why we would do this here. That doesn't make sense, or does it? I think we would always start at 0, no? Vtable. Vtable index. I don't think we need to return here for now. Instead, so we have this. So we know if base class, if base class dot offset is 0, then we need to skip all new virtual functions. Skip new virtual functions. And I think we do this by base offset 0. How about we do an index t base class index 0 base class equals base classes base class index base class index smaller dot size plus plus skip new virtual functions. Base classes, base class index, base class type, skip new virtual functions. Okay, and then vtable. So here we probably want to change that vtable. Base class type. Okay, I need to first understand how we use the index here. So the index refers to base class type, process primary vtable. Base class entry count. I think what we can say here is it starts at 0, and then here we do plus equal base class entry count. Base class entry count dot regular count, and base class how about we call this base vtable entry count, and then we also create a vtable entry count okay, vtable entry count, vtable count, vtable how about we say un16t detour available detour count is vtable entry count dot detour count, and then we say if if base vtable entry count dot detour count if basically detour counts is larger than 0, then well, let's say while available detour count is larger than 0 and this dot detour count is larger than 0. Then we say while or let's say if available detour count is 2 and this as well, or if this equals this, then available detour count is 0. Yeah, how about that? And then plus equal there we go. Okay. I don't think we need this then. Actually, we do. Skip new virtual functions. So int int no let me see. We create a vtable entry count combined vtable entry count, and then we do this loop base class, this one, and then we take these base classes and we take these classes combined. Hold on, didn't we put a function for this already? No. Okay, so here we count base class type dot mv if base class dot m vtables. How about we add a new function? Table class bool let's say vtables.empty. Or let's use the same as this one. Yeah. If size this base class type, and then we do combined base class type dot vtables 0 dot count base vtable entry count. There we go. Make it const count. We need to pass this here, count, and then we do combined vtable entry count plus equals this regular count dot regular count, and then the detour combined dot detour count equals I think here we need to put dot detour count to available detour count. Maybe not. Detour count. Let's do std max detour count and detour count. Yeah. And then here at the end we say combined dot detour count equals std min available detour count and this. We could just say detour count. We can maybe always say if dtalk I think it's fine. std min. So here it should turn to 0 then if this is 0. Otherwise state 2 or 0. Okay. Okay. It's quite a bit complicated here, this portion. Maybe it should be in another function. Maybe we need a function. I guess it's fine for now. Skip new virtual functions. And then we do, my gosh. So basically we want to skip ahead plus equals let's do vtable entry count. I think we need an assert vtable entry count dot combined minus vtable entry index. I think I do something still fundamentally wrong here. Something doesn't look right here at the top. We want... I think I need a break. I can't. I just can't right now. Let's take a break because I totally lost overview of what we're doing here. I totally lost track. I don't know what I'm doing here. I would take a break. Yeah. And then try to continue next session. Yeah. Oh my gosh.